If you're a data engineer, you know that understanding the domain is just as critical as the tech itself. So, in this explainer, we're going to translate the really complex world of finance into the language you already speak: data systems, pipelines, and processes. So, how does that actually happen? We're going to answer that very question by following the data. We'll start with its raw form as a financial statement, track it through a pretty complex pipeline, and see how it comes out the other side as an intelligent, actionable insight. This is basically the financial data lifecycle. All right, here's our roadmap. We're going to kick things off with the bedrock, the source data itself. Then we'll talk about how you create a single view through something called consolidation. After that, we'll cover how we learn to trust the numbers with reconciliation, explore the AI revolution in analytics, and finally, take a look at the rules that govern this whole game. Every single data pipeline has to start somewhere, right? It needs a source. Well, in finance, the two most fundamental sources are the financial statements that really tell the story of a company's health. Pretty much everything else is built right on top of these. So what's the most important thing to get here? It's all about time. Think of a balance sheet as a snapshot, a single photo of the company's health at one specific moment. A profit and loss statement, on the other hand, well, that's the story. It's a video that plays out over a quarter or a year, showing performance over time. That distinction is absolutely critical for how we model and analyze any of this data. And this slide, it's a perfect illustration of that snapshot idea. On one side, you have the assets, that's what the bank owns. On the other, liabilities, what it owes. For a data engineer, this is our raw, structured source table. You can think of it as a clean, two-column schema that becomes the foundation for everything that comes next. Okay, so now we have our source data. But what happens when you have hundreds of these sources coming in from different subsidiaries in different countries, all using different currencies? Yeah, that's when things get complicated. Let's move to the next stage and see how we build on this, creating one single unified view. In the world of finance, this is called financial consolidation. But for us, in the data world, let's just call it what it is: a massive, incredibly complex ETL job. We're extracting data from countless sources, transforming it all to fit into a single model, and then loading it into a centralized system to get that complete picture of the whole organization. And this slide right here highlights just how complex that transform step in our ETL pipeline really is. I mean, we're not just joining a few tables here. We're talking about handling currency conversions, automating cash flow calculations, managing really complex dimensional models for auditing, you name it. These are the real-world data engineering challenges that are happening behind the scenes. So, we've ingested the data, we've consolidated it. But is it right? Because in finance, close enough will get you into a lot of trouble. The next critical step in our pipeline is all about data quality and integrity, or, as it's known in this domain, reconciliation. Historically, this process has been a huge bottleneck. Just imagine teams of accountants manually matching millions and millions of transactions. It's slow, it's expensive, and, it inevitably leads to errors, especially when you're dealing with inconsistent data formats and just massive volumes. It's a classic data quality nightmare. And this is where modern data systems bring in a really powerful solution. By applying AI and automation, we can completely transform reconciliation. Machine learning models can recognize patterns and match transactions at a speed and scale that is just impossible for humans. It turns a painful, error-prone chore into a fast, reliable, and continuous process. So we've automated away the old problems. But AI isn't just about doing old things faster. It's about creating entirely new capabilities. It's about moving from simply reporting on data to generating true intelligence. And here is why that is so important. The volume of data in finance is just exploding. IDC projects it's going to triple by 2027. Manually trying to analyze that tsunami of information is simply not an option anymore. Automation and AI are no longer a nice-to-have. They are an absolute necessity just to stay afloat. The technology that's driving this whole shift is called augmented analytics. This is where AI really moves up the value chain. It's not just matching transactions anymore. Now, it's automating data prep, proactively detecting anomalies, and surfacing insights in real time. This basically elevates our data pipeline from a simple reporting tool to a risk intelligence engine. This chart is a perfect example of the kind of output that Intelligence Engine can produce. Instead of just getting a list of numbers, you get a clear visual breakdown of where revenue is coming from. You can instantly see that asset management is the biggest piece of the pie. This is the end product of our pipeline, turning those raw financial statements into actual strategic business insights. So we've built this incredible pipeline that turns raw data into AI-driven insights. But there's one final, absolutely crucial layer that we have to consider: the rules and regulations that govern how all of this is done. This is the governance framework. So why is governance so important? Well, because as this diagram shows, it's not just about the bank. You've got regulators, shareholders, creditors, and especially depositors. They all rely on the accuracy and integrity of that financial data. These rules exist to protect everyone in the ecosystem. A prime example of this is a framework called Basel III. For a data engineer, the best way to think about this is to see it as the global schema for risk data. It defines the required fields, the calculations, the data formats, and the standards that every single bank has to follow. It's the ultimate set of business rules that our data pipeline must enforce. We've journeyed all the way from a simple balance sheet to a fully governed AI-powered intelligence engine. We've moved from reporting what happened to predicting what might happen. So as our systems get smarter, is the next great challenge to build pipelines that don't just predict risk, but actively prevent it in the first place? Something to think about. Thanks for watching.